Welcome back, students. In this video, we're going to cover, excuse me, lesson 7-5. This is Rhombi and squares. Sorry for the long absence for those of you that have been watching my videos. I appreciate it. Hopefully, I'll get back on track here. I got this one and one more left from Module 7, and then we'll get caught up with Module 10. In the classroom, we did 10-4 today, so it'll take me a second to take my brain back to Module 7, so if I slip up, I apologize ahead of time. But let's get started. So, if you've watched the other videos, so we started out talking about parallelograms, and then we've moved forward. Now we're into rhombi and squares. So rhombi and squares, well, let's just follow the notes here. So rhombi are parallelograms, so all the same rules apply. So opposite sides are congruent, opposite angles. Let's see, what we're adding, excuse me, is that the diagonals are perpendicular, so we get a 90-degree angle. That's going to be all the way around. I'm just going to draw it on the one. And diagonals bisect the opposite angles. So it's kind of showing you here that it splits this guy in half, so each side is congruent. And I'll just do the one up, but it's the same here. So opposite sides are congruent, but it breaks them in half. It does the same on the other. One thing it doesn't say here is that rhombi, they have all sides are congruent. Excuse me. So that's where the rhombus and the square are the same, where they have all the sides are congruent. Let's see. Squares are parallelograms. They're also rectangles. They're also rhombi. They have all the rules for all those guys. So opposite sides, opposite angles. Diagonals are perpendicular. They bisect each other. They're congruent. All four angles are 90. All four sides are congruent. So yeah. So all four sides is like the rhombus. All four 90-degree angles is like the rectangle, and then all the other rules go with the parallelogram for the most part. So that in mind, so we're going to do example 1. You'll do practice 1. I'll do example 2. You'll do practice 2. We'll flip over to the other page. So example 1, if LM, so that's the top here, is 2x minus 9, and KN, so down here, is x plus 15, and rhombus KLMN, what's the value of x? So it's a rhombus. That means the sides are congruent. So that means that LM is congruent to KN, which means 2x plus 9 equals x plus 15. Okay, so let's subtract x from both sides. 2x minus 1x leaves us x plus 9. Over here, these cancel, so you got positive 15. So we're going to subtract 9 from both sides. That cancels. X equals 15 minus 9, which is 6. And that's what they asked us to find. All right, so over here, so this is quadrilateral WXYZ is a rhombus. If angle WYZ is 6x minus 13, and angle XYZ is 8m plus 10, find the value of WXY. So for you listening, so these two angles are congruent to each other. So you put the two equations equal to each other. So that then you use that to solve for m, and then they want WYZ, so you plug it back into. So you'll go WYZ equals 6m minus 13. 6. Then you plug in m right there, minus 13. Then work it out, and that'll help you get your answer. Okay. That is not the answer, so you folks that just turn that in to me, you're I'm going to mark that wrong. All right, example 2 on the left. Sorry, we got some focus issues here. Give me just a second. There we go. All right, example 2. So EFGH is a square. So FG is 8. FH, so that's from here to here, is 14C minus 35. Find EG. Okay, so this guy's a square. That means the diagonals bisect each other, and that means that they're congruent. So first, so JF, hold on, let me see how we want to do this. So JF, let me just do this. JF is 8. JH, JH would be congruent, so it would also be 8. Both of them together are 14C minus 35. So essentially it's 2 times JF, because let's say, so JF is congruent to JH, so we can replace that and just say that JF, well, if we say, hold on, we'll say FH equals JF plus JH. It also equals 2 times JF, because you can replace those. So 2 times JF equals JH. So 8 plus 8, or 2 times JF, is 16. And the other side is 14C minus 35. This is how we're going to solve for C, and then we're going to plug it back in, because underneath here we know that E, because the diagonals are congruent, so EG is congruent to FH. So when we find C, we're going to plug it into FH. I'll put JH up there. It's FH, sorry. We'll say HF. HF. So when we find it, we'll plug it back in here. You'll see. Okay. So 14C minus 35. So we're going to add 35 to both sides. Those cancel. We got 14C here. 16 plus 35 is 51. Okay. Wait a minute. What did... just a minute. Oh, I missed this part. Yeah. Hold on. Yeah. So, but they tell us here FG or FJ. I don't know where I got 8. Oh, I got 8. Yeah, it's not 8. It's not 8. It's 3C plus 8. So 3C plus 8, 3C plus 8. And we're going to go down here and say 2 times 3C plus 8, because we need to know what that is to put it over here. So, yeah, I knew this was all looking weird. So, it's 14C minus 35, and we're going to put this over there. So, let's distribute. So, 2 times 3C is 6C. 2 times 8 is 16. So, I'm going to do this. I'm going to do it like this. So, 6C plus 16. So that's your 2 times JF. All right, so now subtract 6C over here. Subtract 6C over here. 14C minus 6C is 8C. You still have 16 over there, and you still have minus 35 over here. So we're going to add the 35. Add the 35. These cancel. So you're going to end up with 8C equals 51. Divide both sides by 8. C is going to equal 6 point, we're going to round it up to 6.4. Now, where did I plugged it in below. So hold on, scooting down. So now, using this, where did they give us? So, since EG and FH are both the same, we can say that it's 14C minus 35. See, it's the same as FH. EG is the same. So we're going to plug in. We're at 6.4. All right, so 14 times 6.4 is 89.6 as we round, minus 35 is going to make EG equal to 54.6. All right, so over here, you guys, so it's a rhombus, not a square. I think, did we change that? Yeah. So rhombus, not a square, so use the rules for a rhombus to solve for x and solve for y. You can't solve for them together. And then once you solve for that, well, actually, use this to solve for x, and then it's going to ask you what y needs to be to make it a square. And you know what the difference is, so this is your hint. If you need help, let me know. Remember that red box is the difference between a rhombus and a square. All right, top of the page. So I'm going to help you with do example 3, practice 3. You guys, I'll tell you how to do it. If you have any questions, please send me a message, comment on the YouTube video if you're not in my class. But if you are in my class, or at least at First Coast, send a message in Focus or Teams. All right, so example 3, determine whether ABCD with vertices, and it gives us those, is a rhombus, a rectangle, a square, or none. List all that apply. All right, so first thing we do is graph it. So A is at -3, -1, -2, -3, +2. So A is right here. B is -2, +6, 1, 2, 3, 6. C is 2, 7. And then D is 1, 3. I don't have my straight edge, but we're going to... I'm sure some of you guys are looking at it and you're like, oh, yep, that's a... That's a blah, blah, blah. Well, what we have to do in order to find out, to verify, so we're going to use the distance formula. We're going to check consecutive sides, and if the consecutive sides are congruent, then we can rule out that it's a rectangle. We make sure all 4 sides are congruent, then it's a rhombus, and then we check the slope, and that'll tell us whether or not it's a square or not, because if it's a square, it'll have 90-degree angles, and if it's not, it's a rhombus. So let's check. We'll do AB, so we're going to use the distance formula to begin with. X sub 2 minus X sub 1 squared plus Y sub 2 minus Y sub 1 squared. So we'll go AB, and then CD. No, actually we need to do AB and then, well, we'll do all 3 of them. We're going to do, I'll just go here, here. Okay, so what I like to do, so AB, I would do, A would be my X sub 1, Y sub 1, B would be X sub 2, Y sub 2. I would do the same here, just as I have them written. So I'm not going to write that up here to confuse you guys, but I am going to say, so AB, so our X's are -2 minus -3. Notice I said minus negative, so it's going to be -2 plus 3. And then your Y's are 6 minus 2. Now, the reason this is -2 plus 3 was because it was -2 minus -3, and minus negative is when we change it. All right, so 3, a -3 and a +2 make 1. 1 squared is going to be 1, but let's see over here. So 6 minus 2 is 4. 4 squared is going to be 16, so it's going to be 1 plus 16, so it's going to be the square root of 17. All right, so let's look at CD. So we got 1 minus 2, which is 1. And then we've got 3 minus 7, which is going to be -4. So you end up with 1 squared is 1, and then -3 minus 4 is -4. -4 squared is 16. Guess what that one is? All right, so your opposite sides are congruent. Let's see, and they kind of look the same to me, but let's just look. All right, so BC. All right, 2 minus -2. So 2 plus 2. And then 7 minus 6. So you got 4 and 1 again. All right, so 4 squared. And then 1 squared, which is going to be, again, 16 plus 1, which is 17. So we have 3 sides that are congruent, so it's not a rectangle. So let's see, rhombus and square. Difference is, we're going to check slope. And we only really have to check it for one side. We're going to go AB versus AD. So the slope for AB versus the slope for AD. And if their product equals -1, then they're perpendicular and it's a square. But if they don't, then it's not. So let's get the slope. So slope formula. M equals its rise over run, which is your change in y. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So AB is just going to be like it was before. So your y's are 6 minus 2. So AB, 6 minus 2, because that's your y's. And on bottom, -2 minus -3 or -2 plus 3. All right, so that's 4 over -1, which is -4. Let me make sure I did that. No, it's not -1, it's +1. Okay. Sorry, I was like, whoa, man. So that's +4. I'm just going to do this because it's -2 and a +3 make a +1. So anyway, and now AD. So 3 minus -3. So 3 plus 3 on the top. Did I do that? No, I didn't. It's the y's. 3 minus 2. See? Glad you guys are paying attention. All right, so 3 minus 2 on top, and then D is 1 minus 2 on bottom. All right, so that's 1 over -1, which is -1. Well, -1 times 4 is not, so -1 times, or well, yeah, we'll just say +4 times -1 does not equal -1, so not perpendicular, so ABCD is a rhombus. Sorry, I'm getting into that. Don't write in here because you need this. All right, so practice 3. Up to you guys. Go ahead and plot it. Then use the distance formula to see. First check your opposite sides. So it would be QR. So because it's going to be QRST, so it'd be QR and ST. See if those are congruent or not. If it's not, then it's none. If they are, then it's at least a parallelogram. So then you got to see if it's consecutive sides are congruent, and that'll tell you whether or not it's a rhombus or a square. or if it's a rhombus or not, and a square. Then you check to see if it's perpendicular or not, but you won't need to get that far. I'll just tell you it's not a square. So if you have any questions, please let me know. Send me a message. Until next time, have a good night.